Guys, you want to know what the secret was? I just needed to quit Discord and reopen Discord. Isn't that fun? Sorry about that, y'all. Welcome to Safe Hashes with me. So I'm just going to jump right into stuff. So we currently have about 107 people in the chat here, which is lovely. We're going to try to do a lot of stuff on this call. I don't think we're going to need 3 hours of your Saturday. Hopefully, I'm going to be able to cut it down to just an hour. But essentially, we're going to be teaching you all what the basics of what you need to know when it comes to signing transactions. And you are all getting kind of the sneak peek, the demo, the trial run, if you will, of an upcoming Cyfrin workshop that we're going to be giving more regularly on, certifying people in this power, in this ability, because it's come to our attention as the industry, in the industry, that most people, when it comes to signing transactions, are kind of quote unquote YOLOing their transactions. So, if you're a wallet signer and you're in charge of a wallet that has $1 billion in it, you should really know what you're signing. And that hasn't been the case. Now, that hasn't been the case for a number of reasons. Number one, signing stuff has been difficult to understand what your wallets are saying. A lot of hardware wallets and software wallets don't do a great job of showing that information. A lot of them are fixing that now. But that's not really an excuse if you are in charge of a lot of money on your wallet. So we're going to be giving you all the kind of the rundown of how this works. And like I said, this is kind of a trial run, so bear with me. Clearly, I didn't even know how to get my Discord audio working. This is kind of a trial run of this type of workshop, and I'm going to be iterating on this to make it more fun and more engaging moving forward. So please bear with me as we figure this out. So let's go ahead. Let me show what we're working with here. Working with nothing. Ha ha ha. One sec. Okay, cool. Great. Let's jump into it. So yeah, essentially we've been seeing kind of this uptick in these different types of attacks. The North Korean team has been heavily at work. They've decided, hey, you know what? Hacking smart contracts is too hard. People are stupid, though. Let's just go back to hacking the humans. That worked way better. And they've been cashing out on some big paydays, switching from hacking smart contracts to just hacking people. People are so much dumber. So North Korea, responsible for the $1.5 billion Bybit hack. For those of you who are unfamiliar with this hack, essentially the Bybit team they are an exchange, and they signed a malicious transaction that allowed for the North Korean team to basically steal all their money inside of their wallets. Why? Well, because the team who was doing the signing wasn't verifying what they were signing. Now you might think, hey, that's crazy. Why would you ever do that? Well, to them, it looked like this is a really minimal transfer. This is kind of a routine event. But what actually ended up happening was the Safe UI itself was hacked. So this website, which we're going to be going over a little bit more today, was hacked. And it was showing them a transaction that said, hey, this is a good transaction. This is safe. Go ahead and send it. But this was hacked. And what actually got sent to their wallet was a malicious transaction. And they went ahead and signed it. So we're going to learn how to protect ourselves against that. If you want to learn more about the Bybit hack in particular, I've got a couple videos about this on my YouTube channel where we break down, what happened, what were the smart contract changes that they made, what were the how was the front end compromised, et cetera, et cetera. So for this presentation, we're going to be going over basically, okay, when your MetaMask or your hardware wallet pops up and says, would you like to sign this? And it gives you this lump sum of random crap. What is going on? Like what are we actually doing here? Like how do we know if this is safe to hit confirm or sign or etc.? Now, in particular, who this workshop is for, anyone who wants to be able to sign transactions with some assurance. In particular, this is for developers and security professionals. If you're non-technical, you're welcome to participate in this workshop as well. But some parts of this might be a little bit challenging. We're going to be using a tool to help verify a signature, to help verify signatures and make sure we know what we're doing. So here's the agenda. I know we set it aside for 3 hours, but hopefully we're going to be much quicker than that. We're going to start off with wallets because this is where everything starts. What type of wallet should you use? Because the wallet is your gateway to this whole ecosystem. And then we're going to just jump into, right into some hands-on learning, how to verify our transactions with MetaMask, and then how to verify transactions with a hardware wallet as well. So before we get started, if you could go ahead and enter into the chat here, your experience level with wallets and signatures. Please do this in one message because we have 100 people here, which is awesome. Your experience level with wallets and signatures. Number 2, if you have a hardware wallet you'd like to trial today, and this must not be a hardware wallet that you use for real stuff. This must not be a hardware wallet. This must be like a separate hardware wallet. And then finally, if you have a MetaMask wallet you'd like to trial today, and of course, if you are, I am sharing my screen. Can you guys not see my screen? And if you have a MetaMask you'd like to trial today as well, which if you're taking Cyfrin Updraft, you 100% should, because I told you you have to. Yeah, I'm not sharing my face. I'm sharing my screen. Yeah, so can you put into the chat the answer to these 3 pieces of information here? Hi, now you can see me. Hee. Okay, so, okay. Inner level, no, yes. Okay. Can you move your footage of yourself to the left? I can, but I don't want to. I'll just get rid of myself. So a lot of people say they don't have much wallet experience. They don't have a hardware wallet. They do have a MetaMask, okay? Okay, cool. About to finish Foundry Fundamentals, but there's no signature stuff. The signature stuff comes in Advanced Foundry. Beginner, no, yes. Beginner level, can't see your screen. Okay. Okay, cool. So that's enough. That's enough information there. Okay, let's continue then. Okay, so first off, let's start with wallet recommendations. So I'm going to share this link in the chat here. I actually have to go update this because I'm in the middle of kind of a big hardware wallet deep dive. It was a little bit of a sneak peek on some of my testing. I bought like, a couple $1,000s worth of hardware wallets, and I'm like using all of them to run like 100 transactions and signatures and do all this stuff and figure out which ones are the best. So I'm going to update this article shortly with all the findings from this. But just kind of a quick rundown on wallets. So if you're a complete noob, if you do not know how to actually verify your transactions, at this time in Web3's curriculum, or in the Web3 era, I think you should use a custodial wallet. And I know that that's blasphemous because, not your keys, not your crypto. However, so many people have no idea what they're signing and they don't bother checking what they're signing that it's probably better to trust somebody else than trust yourself. Now, we teach on Cyfrin Updraft all the information for you to be able to learn this stuff. So you should not stay here. But if you don't know what you're signing, I don't want you signing stuff. Like that's the way it is. Like the downside here is if one of these exchanges goes under or one of these custodial wallets go under, you lose all your money, which obviously super sucks. Custodial wallets kind of defeat the purpose of crypto in the first place because they're holding your crypto. Then like what the hell? Like that's way worse. Because anybody could send you a malicious transaction, you could lose all your money. So if you don't know what you're signing, first off, if you're here and you're like, hey Patrick, I want to learn about this signing stuff. If you drop off this call and you don't learn about signing, then you should take all your money off your self-custodial wallets and put them onto exchange because you'll sign something stupid and you lose all your money. And that's just the way it is. So next up, yep. Once you learn how to sign stuff, then you can move stuff to, browser wallets, desktop wallets, hardware wallets. My ultimate recommendation is to use an advanced multi-sig for everything that you do. And that's what we're going to be going over today. The safe wallets are kind of the most popular one. They are multi-sig wallets. They require multiple signatures. These are great because even if you're like, Patrick, I only want one wallet. I only have one wallet. Well, what you can do is you can sign. Excuse me. This is what you should store for like long-term storage for like holding lots of crypto. If one of your wallets gets compromised, the beauty is you can just swap it out for something else, which is fantastic. Whereas if you lose your private key, you're just effed. So that's kind of my quick recommendations here. I highly recommend you all read this article to learn more about different wallets. And that's pretty much it. So just to recap on this article here. Number one, if you, I saw a lot of people dropped off the call. If you dropped off the call, those are the people that should probably keep their wallets on centralized exchanges because they don't know what they're doing. Until you're confident that you know what you're doing, leave your money here because you're going to screw something up. Once you learn what we're going to be teaching you here, then you can move to something better. Any questions on that before I move on? No, it's very clear. Okay, great. Okay. So now we're actually going to move into verifying some stuff. And we're going to do it live with a safe wallet here. So I am on the Sepolia testnet. And I'm going to show you, I'm going to do a couple things and I'm going to pause and ask questions. I'm going to ask you, is the transaction safe? Is the transaction what we want? And you're all going to need to find out by watching me if what we're doing is correct. And when it is not correct, or when it is correct, I'll tell you where it's correct, etc. So I'm on this multi-sig wallet. It is a one of two signatures, which means that you only need one of two people to send a transaction. So first question here, is my wallet set up? Here's the scenario. I am the CEO of a multi-billion-dollar exchange, and this is going to be my wallet. I can even pop this out over here. This is going to be my wallet on Etherscan that controls $10 billion. Is it a good idea for this to be a one of two signatures multi-sig? Yep, you're all pretty much got it. People who answered no, this is a terrible idea. So what does a one of two multi-sig mean? Well, so um, this address here on Etherscan is a wallet. However, unlike a wallet inside of like a MetaMask here, if we go to like the settings, we can see that this is a one of two multi-sig. So there's two addresses in here. There's ledger test in MetaMask, and there's this Anvil 10, which we'll talk about in a little bit. This means that if one of two of these signs something, a transaction can go through. Typically, we want at least a 2 or 3, where you need 2 people to sign something out of a possible 3. 5 of 9s are pretty popular, 3 of 5s, et cetera, et cetera. If you're going to be storing lots of money, you obviously want more than this. So right away, this would be dumb, but because I don't want to have to wait 10 years for 10 people to sign stuff, this is what we're going to be rolling with. Now, let's create a transaction here, shall we? New transaction. I'm going to use this transaction builder. And what we're going to be doing, what we're going to be doing is we're going to be just calling approve on this contract address here. And I'll post a link to it in the Discord chat here. This is an ERC20 token wrapped Ether. And again, I know there's a little bit of kind of knowledge I'm not really explaining. Like if you're unfamiliar with ERC20 tokens, if you're unfamiliar with if you're unfamiliar with ERC20 tokens, if you're unfamiliar with MetaMask, this is going to be I've already introduced a lot of terms that you're unfamiliar with. Hopefully you're all with me so far. There's a couple questions actually in here. Yes, we are showing the screen. If you look at my speaker, you can see that's me showing the screen. I wonder if I can make it bigger for y'all. And then a question for you all here: who has never heard of MetaMask before? Who's never heard of MetaMask before? Who's never heard of MetaMask before? Has everyone do I need to explain what MetaMask is? I don't think I do. Everyone's heard of MetaMask. Everyone knows what an account is. Well, you could have. I mean, you could have heard. So I guess I should have gone over some of the assumptions here. So the assumptions are, you know what MetaMask is. You've heard of a safe multi-sig before, etc. Okay, cool. Sounds like it's good enough. Anyways, so what we're going to be doing is we're going to be sending some of this token here. So this is an ERC20 token. This is a WETH9 token on the Sepolia chain. So I don't think I have any in my account here. But what I can do is in my MetaMask, I'm going to import the token. I'm going to paste the token address in here. Next, import. Now we have some WETH9 in here. Now I'm going to mint myself a little bit of WETH. I'm going to connect to a MetaMask here. Call deposit. Do I have any Sepolia ETH? I have a tiny bit of Sepolia ETH. Give me a second. Sorry, I know it went black. Relax. Gonna just send myself some Sepolia on a different account. I think in the future versions of this workshop, I want to be using Tenderly virtual testnets to make everyone's life a little bit easier. I was actually trying to do that before the call today, but the Safe UI wasn't playing well with me. So, okay, so cool. I have a little bit of Sepolia ETH in here. Now we're going to do 0.01. I'm going to call this deposit function. And what this is going to do is it's going to deposit 1 ETH and mint me 1 WETH. Now we can already get into verifying some transactions here. So before we even look at a safe multi-sig transaction, we can look at a basic MetaMask transaction. Isn't that wonderful? So here is what we see in our MetaMask. And right at the top, we see estimated changes. We see all this information here. So before we even get started doing the safe stuff, let's do a little recap of what we're trying to do here, and then let's see if this transaction is actually doing that and how we can verify this transaction is actually doing what we expect it to do. So we're not even talking about multi-sigs. We're talking about verifying a basic transaction here. So what are we trying to do? Well, we are trying to deposit some Ethereum and get minted the exact same amount of Ethereum in terms of WETH, which is a wrapped ERC20 token. It is basically an ERC20 token version of Ethereum. Why would you want to do that? That's a long story. Trust me, there are good reasons for you to want to do this. Now, question, how can we verify this is doing exactly what we want it to do? Let's look at the top. We have this estimated changes bit. It says minus 0.01 Sepolia plus 0.01 of this address here. I'm unfamiliar with this address, so let me do a little look up Areno on Sepolia. Paste this in. Aha, this is indeed the token that I wanted. Yay, huzzah. So, oh, do I have to like redo that again? Oops. There it is. So I said, okay, cool. I'm on the Sepolia network. Great. And I have this estimated changes. Cool. This looks good to me. Is this safe to sign based off of the amount of verification that I've done so far? I see estimated changes at the top. I go, hey, that looks great to me. I'm going to get minus 1 Sepolia ETH plus 1 of this WETH ERC20. That's exactly what I want to do. I'm going to go ahead and confirm, right? A whole bunch of you, go ahead, keep putting in the chat. Come on, be brave. Be brave. Am I good to sign this? I see some yeses. I see some nos. If yes, type Y yes. And if no, type Y not. And for those, in particular, for those of you who said yes, please tell me why yes. Okay. We got some good chat answers. Check the hex. Everything looks good. No, it could do other things on top of the deposit. You confirm the contract address of the token you were trying to get. No, why not? Okay, this has already been great. So I want somebody who said yes. So everyone stop typing. So somebody who said yes, please tell me why you think yes. All we checked was the contract address, the network, and estimated changes. I can see the deposit method. Okay, well, I'm going to stop playing around now. So based off what we checked, which was the network, the address, excuse me, the network, well, yeah, and the address, and the estimated changes, that is not enough information. These estimated changes at the top are, is my screen backwards, by the way, or is it like the correct way for you guys? It should be the correct way. Is it backwards? It's good. Okay. These estimated changes are just estimated changes. I, as a smart contract developer, me, Patrick Collins, I could very easily trick MetaMask into saying estimated changes that look like this, and then totally destroy and rug pull you. Because I'm really good at coding smart contracts, and I'm really good at doing that type of stuff. So estimated changes are not something that we can trust. So if you see estimated changes and you go, oh, this looks good, it's not necessarily good. I can front run your transaction. I can hot swap the code if it's a proxy. This is not safe. This is a nice indicator, but this should never, 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 never be all that you check. So great. So we know we can't rely on estimated changes. However, these are nice to have. So we go down. We say, okay, interacting with this address, we want to check this is the correct address we're working with. I have already done that, which was great. We checked, and it is indeed the WEF9 address. This is when you would, you double check, like, oh, like, is this, you'd go to like the docs, is this the correct contract, blah, blah, whatever. This is indeed the correct, this is indeed the correct contract address. Great. Now I see method, which says deposit. Now, the next question. Now, this is a much harder question. The method says deposit. And we have amount 0.01 Sepolia ETH. That looks good to me. Is checking all of this enough for me to send the transaction? I've looked at all this. Is that enough? Can I send the transaction? No. Why not? Why is it not enough? Look at the hex. Okay, so some of you have taken Cyfrin Updraft. I love the fact that you're all saying look at the hex. And I agree. No, it's not. Look at the hex. As developers, as security researchers, what I want to tell you is you should always look at the hex data here. This is the transaction that you're sending. You're sending this data to this contract. Now, this is something where if you're non-technical, you're like, what do you mean, like, verify the hex call data? Patrick, you're crazy. I'm not going to do that. Well, I don't know what to tell you, because maybe you shouldn't be signing transactions. This is what we're actually doing. So what's cool about this, though, and some people actually might say, hey, I actually do think it's enough data that we have, because essentially all I'm doing is checking that hex call data is the deposit method, right? So for those of you who have taken Cyfrin Updraft, you know that this hex data, this is the first 4 bytes of the hex data, which stands for something called the function selector. So this hex data here is gonna represent the function that we're calling. We do want to make sure we're calling the deposit function. The reason we don't want to trust this method thing here is because sure, it's saying deposit, but maybe there's some extra call data that's being prepended, or there's like some extra data that's making it doing something sus. Once again, I, as a smart contract developer, I am smart enough that I can trick MetaMask into saying deposit, but do some other malicious stuff. So what we can do, though, is we can see this this hex data, and we can make sure that the function that we're calling matches this exactly. So I want to call the deposit function. And so what I can do is I can use Foundry's cast, which, if you don't have Foundry, Foundry ETH, lol. Give me the Foundry restaurant nearby in the Boston area. So this is the Foundry tool. If you're going through Cyfrin Updraft, we use this. And what we can do is we can use Foundry to get the hex call data of the function we're expecting to call. So we're expecting to call the deposit function. So I can do cast sig deposit. And this is called the function signature here. Oh, sorry, I totally made the format of this crap. Hold on. This is called the function signature. It's like the name of the function and all its parameters. And this cast sig function, which comes built in with Foundry, will return us the function selector associated with this function, right? Because we want to make sure two things. We want to make sure we're calling the correct function on the correct address. We've verified it's the correct address. Now we're going to verify it's the correct function by checking this call data. And I can see it is the exact correct call data because I do a little copy of this, Command F, and I see it is exactly this. Nonce looks fine, network stuff, whatever. So now, is this safe to sign? Now can I sign it? I've verified it is the correct address. I've verified the hex data is the correct function. Now is it safe for me to sign? For those of you who said no, why not? Somebody says deadline. What does deadline mean? Verify the data being passed to the function. Said Equius. What if it's a delegate call? Sign function can be used again. Sig replay, sig replay. Oh, I'm so glad this is happening. Oh, this is great. MetaMask. Okay. Oh my God! This chat is amazing. This chat is amazing. This chat is fantastic. Because this chat is so fantastic because a lot of you are saying, hey, this isn't safe to go yet, but you're actually wrong. This is safe to go. And let me explain why. So a couple of people said, hey, you need a deadline. You need a deadline in order to prevent against replay attacks. So there's no slippage here. There's no this is a basic transaction. There's nothing this isn't the way the RLP and that's a much longer conversation. You're not I don't really want to explain RLP encoding. That's a much longer conversation. Why do you think there's no replay attack here? Because we're not sending a transaction that takes like a signature parameter here. When we confirm this transaction, we're confirming it, on this network. Let me actually, you know what? Who here knows what RLP encoding is? Yeah, I don't feel like explaining this. If you want to learn more about what transactions are, go to the ETH.org website. You can read more about transactions here. essentially, yeah, actually, so Equius had Cody explain replay attacks. Um, An attacker can duplicate a user transaction on different chain versions, potentially leading to unintended transfers of assets. So you don't need a deadline here. You don't need uh, uh, really anything. This transaction works for this network, and that's it. So you'll see on different. We're not going to go over that here, but like replay attacks are when you're going to be like taking signatures as an input to a function, which we're not doing here. For those of you who are concerned about like replay attacks on this type of transaction, we talk about replay attacks in the security portion of Cyfrin Updraft, and it's not applicable here. So we don't need a deadline. We don't need like signature transaction prevention. I don't really want to go super deep into that because that's like a really long. But CodeCap person in the chat, anybody who said no, we can't send this yet, thank you for being here. Somebody else said MetaMask UI could be hacked, and this was actually a great point that somebody brought up. So when you're sending these transactions, you want to know what your trust assumptions are. So what are our trust assumptions here? We are assuming that our browser is not hacked, right? Where's the source of truth here? Is the source of truth the Etherscan website? Well, the Etherscan website is going to send us the data that is populated on our MetaMask here, right? Etherscan sent us this data that's being populated here. So if Etherscan is hacked, that doesn't matter to us because we're verifying at the source of truth. We're verifying at the wallet level, which the wallet we're using right now is MetaMask. So if somebody said, hey, if your browser is hacked, then yes, you're right. It wouldn't be safe to send this. Now, this is where understanding and knowing what your trust assumptions are is actually really important. I said, is this safe to send? And I said, yes, but that's actually assuming that my browser is safe, and it's assuming that my that the address that I'm interacting with is also safe. So you always want to understand your trust assumptions. Number one, we are assuming that the address we're interacting with, because it's the correct address, it's not going to rug pull us. So there's a little bit of trust assumption there. We don't want to have to audit every single contract that we interact with. That's ridiculous. And number two, we're assuming that our Brave browser and our MetaMask is also safe. Now, this is why a lot of times hardware wallets are better than your software wallets. Your MetaMask and your browser are a lot easier to hack often than your physical like hardware devices, right? Because you're using your computer every day. You're using, your computer you turn off and all the time. This is one of the reasons why hardware wallets are better, because your MetaMask and your browser is much easier to hack. You download a PDF, you click it. It installs some stupid malware on your computer, boom, you're screwed, right? Maybe this transaction shows up like this, we hit confirm, and boom, we send all of our money away. This is actually why for signing big amounts of money and a lot of money, the recommendation is actually to have a separate device that does all the signing. So for like Bybit, for example, what's something they could have done to mitigate risks is have a completely separate computer that does all the signing of these transactions. But so those are our trust assumptions. The address information is correct, and the browser and MetaMask are actually safe. So this was great that Ellamore brought that up. That is a trust assumption here. What's next? Some people also said, hey, Patrick, you didn't check the data. We only checked the function signature. Well, this was kind of a gotcha, because since this deposit function doesn't take any arguments, this is all the data. The function selector is also all of the call data. So again, this piece of hex data represents the deposit function, and since there are no arguments to be sent with the deposit function, this is all the data, right? This is the whole thing. So we could even see the arguments. We could do like cast call data, deposit, and then paste this in, and it'll say That's it, buddy. Like, there's no other data. Um, so with all this information, yes, this is now safe to send. Um, any other questions? Yeah, like an air-gapped or DMZ network just for executing transactions for Bybit. Yep, like an air-gapped device, um, a separate computer for sure. But I wasn't paying attention. I assumed you were passing an argument. Yep, no argument here. Okay, so now I'm going to go ahead and send this, and I'm glad we got this part out of the way because now we're going to. This is just like a basic transaction, and we already have disagreements on how to verify this stuff, right? But that's what we want to do. We want to check the call data. So great. Confirm. Oops. And now I've definitely lost my page. Okay, it's going through now. Let me get rid of myself. It's gone through. So now if I go to tokens, I see I have it's kind of small, but 0.01 WETH. Great. Somebody said, from Etherscan point of view, that contract is correct. That's another good point. I kind of was assuming that Etherscan wasn't hacked. So that's another trust assumption that you want to keep in mind. But I know this is the correct address because I deployed this address. Yeah, you could also check gas spent. Like there's a number of parameters you want to check, but we checked the address was correct and the call data was correct, and that's good to sign. That's it, right? Cool. So now we have a token. So let's do a more interesting transaction though. So we have this WETH now. I'm going to transfer the WETH to I have all these like random wallets to another wallet. I'm going to send 0.0001 WETH. Continue. Now I have this to review. We would go through the exact same process here, except for when we get to the bottom, we see the data, we see MetaMask actually kind of decodes the transfer function for us. So it says data function transfer, param1, param2, which is really nice that MetaMask does this. If we don't trust the MetaMask UI and its decoding, we can hit this little copy button here, pull back up this. We could do cast call data transfer. What is it? Address uint256, uint256. Paste in the call data and transfer address uint256. Parser error. Invalid string length. Cast call data. Transfer address uint256. Well, this is actually good too because if we get an error here, we can go call data decode. Oh, whoops. I'm an idiot. Call data decode. Sorry. Which is, if you see anything weird, that should be like, I'm not going to send this, but I was just being stupid and using the wrong keyword here. Call data decode. This will decode our call data into the parameters. So it's saying address. It's saying the first parameter is this address. This is who we're sending to. And then this second one is the amount, 1E14. If both these look correct to you, we have successfully decoded the call data. We can confirm it matches what's in MetaMask, and we could hit confirm, but I'm going to cancel. So, because I've already done that, but. So we've checked call data here, and pretty sure we're going to check signature data on MetaMask as well. But that's the basics of stuff, right? That's how we check the call data in our MetaMasks. And if we're signing stuff in our MetaMask, if we're signing transactions, this is specifically for transactions, that's how we want to verify the call data. Any questions on verifying the call data here? We go through this on Cyfrin Updraft as well. We also have some YouTube videos that go over this as well. But this is kind of the first step. Are there any other questions on doing that? It's hard to check if using your phone. There's no Foundry, Cast, etc. Uh, yeah. I don't recommend signing transactions on your phone for that reason. There's a couple types of transactions that I'm pretty good at verifying with like just my eyes. Like I've seen so many transfers that I can like literally look at transfer call. I can like look at this and I can be like, oh, okay, yeah, I know what that's doing. Which is like because I stare at call data all day. Like I can tell right away. I go, yep, that's the function selector. Yep, this is who is being sent to, and yep, that's the amount. And then I've seen, I know what that number is. Unfortunately, that's the beauty of staring at call data all day. You just can't, you can sign stuff like this on your phone because you know exactly what the call data looks like. Okay, but let's get into the more interesting stuff now. Now we're going to go over to a safe wallet, a multi-sig wallet, and here's where we start to get, we start to ramp up here. And I'm going to have you all join me pretty soon in verifying some transactions. I'm going to have you pull up the safe UIs yourself, and you can sign stuff, you cannot sign stuff. Um, uh, yeah, but let's start here. So I have this multi-sig wallet address, this one right here, and I want to send a transaction for this multi-sig. Whenever we send a transaction from multi-sig, it's a 2-step process, right? So, or a 3-step process, I guess. So number one, you propose the transaction. Why does it keep doing this stupid thumbs up thing? You get all the signatures, and then you execute. So it's basically 3 steps. So let's start with proposing. Excuse me. And we're going to do the exact same original one. We're going to deposit. Actually, you know what? Let's call approve. On this WETH9, this token address, I'm going to paste the address in here. I'm actually going to grab the ABI as well. Contract ABI. And we're just going to call approve. We're going to call the approve function on ourselves for 0 amount. So a pretty harmless transaction. But this is what our transaction builder is saying we're going to do. I'm going to add this new transaction, and we're going to see if we can verify this actually does what we want it to do. So I said add new transaction. I'm now going to create batch, and now I'm going to send the batch. Here's what pops up on my UI. I see advanced details. I'm calling approve on wrapped ether. This address, that address looks good. Value is 0. We see all this transaction data, which is cool. Transaction hashes. What the hell are these? We'll talk about that in a second. Transaction checks, blah, blah, like whatever. And we scroll to the bottom. We see confirm. You're about to read and confirm this transaction. Would you like to execute this transaction immediately? The reason we see this is because since this is a 1 of 2 signature, the safe UI is smart enough to know, hey, like if you sign this, you can also execute it right away. So if we hit yes, execute, it'll both sign and execute. If we do no later, it will just sign, and then we will have to execute it later. Excuse me. So what we're going to do now is, for the time being, we're going to hit no later, and we're going to sign. And the question, once again, is, can we sign this? Is this safe for us to sign? Let's take a look. And if you've never, and if you've only sent transactions before and you've never signed transactions, the answer should be no, because you probably don't know how to verify this signature here. So, having this here, is this safe for us to sign? And why? Yes or no? Is this safe for us to sign? Yes or no, and why? The signature dealing, no need to verify the hex data. Now it's time to verify the hex and the deadline as well, said code cap. No, we need to verify. No, we need to verify the hex data. Okay, cool. So you guys are following, are starting to pick it up, right? We need to verify the hex data. But if I scroll down, it says signature request. What is the hex data? Okay, let me, what did we do before? Well, we hit that copy button. So I'm gonna hit that copy button again. And I'm gonna paste it in here. What the hell? What the hell is this? Don't worry, I'm gonna show you what the hell this is. So when I hit that copy button, and I pull this up, I'm gonna call this hold on one sec. Hardware workshop. Was this .json? Yeah. Cursor is lame. Blasphemous, I know. GitHub Copilot, I think, is better. Cursor's too invasive and stupid and pisses me off. Anyways, so when we hit the copy button, I also don't like windsurf. Shoot me. When we hit the copy button, this is what we see. We see all this stuff here and all this stuff at the bottom. But wait a minute, Patrick, that's totally different than what we saw before. Patrick, what the heck? When we did, wait a minute, when we went to the contract, we did write contract, connect, yeah, blah, blah, blah. MetaMask, blah, 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 deposit, 0.0001 or whatever. Wait, let me cancel this one. When we hit the copy button before, what do we get? Right, I'll go back here, paste it in. We got just this hex data. What the heck? Let me cancel this one, go back here. Let's try again, sign. Now when I hit the copy button, I get this, come on, format, there we go. I get this wackadoodle nonsense. What's going on? What's the difference here? Well, the difference here is this is a signature request, which is different from a transaction, right? So this is saying sign something versus the transaction is saying send something. Now, what's kind of confusing is that when we send a transaction, we still have to sign something. We sign the transaction and then we send it. Here, we're just signing. We're not doing any sending. But we're signing something as an input to a function. So if we go back to our safe wallet, and I gotta zoom out just a little bit. Whenever you send a transaction on a multi-sig, let's go to sepolia.etherscan.deth.net. This is a cool trick to kind of get any Etherscan contract into like a VS Code look. Oh, this is the proxy, son of a. Where's the implementation? More options. Is this a proxy? Okay, here we go. Whenever we send a transaction on a multi-sig, you're calling this function, exec transaction. Your multi-sig wallet is a smart contract that acts as a wallet. And to send any transaction, you have to send a transaction, which is kind of confusing, but let me visualize it. So if I want to send, 10 WETH token, I first need to call exec transaction, which will then call the transfer function. So every single transaction that you send through a multi-sig gets called through this exec transaction here. So, and in this exec transaction, we have this signatures parameter. So we need, as an input parameter, to call exec transaction with a list of signatures. So we need to sign signatures we need to sign all of this data and add it as a signature. And in here, there's a little verification bit. There's a little function called check signatures, which takes all the data and makes sure that the signatures you send are correct. So the first thing we need to do is sign stuff. And this is why we get prompted with this weird JSON object, because this is what we're actually signing. We're signing this data. It's going to generate this signature object. Where did that go? Did I delete that? Yeah, it did. Exec. It's going to sign the signature object, and it's going to send that as an input parameter to our exec transaction function. So, back to our MetaMask. So we need to now verify that this data is what we want. We need to verify we are signing the correct thing. So how do we do that? Who here knows how to verify what we're signing? Two questions. Who here knows how to verify what we're signing? And if you're lost, also tell me. Okay, so Domini, cast call data decode the function and parameters and add the data. So what call data though? What call data do you want us to decode? Also, Microsoft Word is the best text editor, not Notepad, not Cursor, not VS Code. That's a terrible joke. Just kidding. It's that nobody take that seriously. Are hardware wallets now adding this kind of option to have this process available? I will show you a hardware wallet soon. We're going to take a break in the next 15 minutes, by the way, because I've been rambling for 80 minutes. I opened Vim 3 years ago, and I'm able to close this. So how do we verify this? Somebody said cast pretty call data. I don't think that's a thing. Oh, it is a thing. Oh, what the heck? What does this do? Tries to decode the call data using. Oh, okay, cool. Actually, I didn't know that. I've been using it the hardcore way the whole time. Add and function, go back to ID to pull the function selector. So there's a number of things to kind of unpack here. So this is the data that we're going to be signing. Okay. All this stuff in here is what we're going to be signing. And we want to make sure that this is like what we want to sign. So whenever we sign something, and this is in the EIP 712 format, we want to make sure the EIP 712 data is correct with the message hash, domain hash, and safe transaction hash. So back in the safe UI, it actually gave us these transaction hashes: safe TX hash, domain hash, and message hash. These are the things we want to verify are correct that we are signing. These are created based off of all of this data, all of this data in here. So all of this data gets basically hashed together to make these hashes. Now, in a perfect world, ideally, our wallet would give us those hashes as well: the safe hash, the domain hash, the message hash, but MetaMask does not. However, we can technically derive these hashes from what MetaMask gives us. And this is where we can use the Cyfrin SafeTX hashes tool or Pascal's original one. We're also making a Rust edition as well. But we want to verify our signature here is correct. So what we can do is after you install the tool with safe hashes or safe hashes, oh, I don't have that one. I have this safe underscore hashes. By the way, if you're ever creating a CLI, never use underscores as the command. That's like so stupid. I was like kind of in a rush when I made this tool, and then I felt like I couldn't go back after I made it. So we're going to use the safe hashes tool to verify this signature is actually what we want. So we're going to do safe hashes, and we're going to pass in the address of our multi-sig, which is going to be this one here. We're going to put the network, which is Sepolia. We're going to put the nonce, which is number 0. And we're going to use something called offline mode, where we pass in like the raw data, essentially. We're going to pass in data, which this is the call data, and we're going to get back to this in just a second. Data, and it actually automatically sets a lot of these other values. Actually, it automatically sets a lot of these other values to default. So 2 we do need to add. Oops. --2. And it sets value to 0. It sets all these to 0. It sets all of these to 0. But if you want to add these in as well, you can do like -- gas price, blah, blah, whatever. Oh my God, I just deleted the whole thing. Save hashes, -- address. I gotta do the whole thing again because I -- network Sepolia, -- offline, -- nonce 0, -- offline, -- data. And like I said, we're going to get to the data in a second. Is that everything? Did I miss something? I missed 2. -- 2 is and now it'll calculate the hashes for us. So we can even see if this hash matches what we see in the safe UI, and we do indeed see. So if our MetaMask gave us the safe transaction hash, all we would have to do is compare the safe transaction hash, and we would be good to go. It does not. So we have to actually manually verify kind of all the parameters in here ourselves. So we're assigning this SafeTX hash. We have to check the 2 address. We go to like Sepolia Etherscan or whatever. I'm going to say, yep, this looks good. Value is 0. Yep, that's good. Data. Who knows what this data bit is? What is this data bit? Message hash. Nope, it's not the message hash. Good guess though. Hex to the action. Yes, exactly. This is the hex of the data. So remember, of the data to the action. What does that actually mean? Well, remember, whenever we call a function on our multi-sig, we're going to be passing in a list of signatures, and we're going to be calling this function, which will then call another function. So we're going to be calling, remember, we'll call exec transaction to then call the, the approve or the transfer or whatever. This data here is the hex data of that second call, right? Of this approve / transfer. So we actually want to decode this data to be so that it is what we expect it to be. Exactly the same way we decoded a regular transaction. So what I'm going to do, cast call data decode. What are we doing? We're calling approve. I know it's been forever since we looked at this, but remember, we're calling approve, right, for 0 amount. So we're saying, okay, call approve. What's the... so many tabs. Which takes an address and a uint256. So we'll say address uint256. And this is the call data that our MetaMask is saying we're going to send. And now we're saying, okay, this is the address we're calling the approval on and for this amount. So we can go to the UI. We can say, oh, that is what we want. And the value is what we want. Well, actually, we would say, okay, is this the person we're trying to approve? It sure is. And is this the value we're trying to prove? It sure is, right? So this data is the actual transaction that we want to send. And then the rest of these look fine to me. One of the most important things to always check is this operation. If it's a 0, this is going to be a basic call. If it's a 1, it's going to be a delegate call. And if you see it is a 1, you should panic a little bit. I have a question, though. Is the byte 32 the CAC256, SafeTX, Uint256, etc.? Which byte's 32? What are you talking about? The data we see. This data? No. So this data is the call data. Here, actually, let me show you. If I were to go back to the contract here, and I were to just call write contract and call approve on, I think it's this address. Yeah. This address for this amount. All right, let me cancel this one. Cancel. And hit write. And I grab the call data by clicking this button here. The data we see in our MetaMask is actually exactly this. So if I were to send a transaction, I would get this call data to send directly to this contract. But for signing this, let me cancel this one. For signing this, the data we see in here is the exact same data if I were just going to directly call approve. But since, again, I'm calling the approve through my multi-sig, I have to call exec transaction first, and then we call approve afterwards. And so that data, so this data here is the exact same data as if we were just call approve directly on the contract itself. Does that make sense? Where the constants are. In here? Wait, what do you mean? The top code of the safe? Like the code in here? Is this version 1 or 2? Version 1 or 2 of what? I'm not sure I'm following. Not sure what the question is. Well, I'm gonna finish this this example and then we'll pause, take some questions. So I just verified this call data, right? Cast call data code, and I see that those are correct. So this looks good to me. The rest of these look good to me. So now I can feel safe to confirm this. Now this process is going to look a little bit different for hardware wallets, and I would actually wish MetaMask would change the how they do it too, but we'll talk about that in a bit. Once I confirm, you'll see the approve is now in queue, and I can see it's now, I now have a new transaction in my queue, but it is not executed. All I've done is signed it. So back in the exec transaction function, I now have created the signature I'm going to add to this signatures section here. So every call of approve has the same hash. Every call of approve with the exact same parameters have the same hash. Yes. Okay. I see what you're asking. Um, uh, the type hash. So this is version 1.3.0. In my safe TX hashes script, it automatically calculates the type hash. This is actually one of the reasons why I wish the MetaMask would show you the domain hash and message hash, because that would give me more confidence that it was actually doing it correct. So yeah, you're looking at the type hash. I guess what's the question that you have with this? So the data we saw in the metadata isn't the type hash, since it doesn't display EA P712. It is not the type hash. Let me show you something. So so the type hash is like basically this hash that tells you what the types are, getting leading into like a message hash and domain hash. Um, the data we saw, the metadata, was not the type hash. No, the data we saw was like just the data um, for the approval. MetaMask actually doesn't show us like what you the message hash or the domain hash is, which is what you need the type hash for. Um, for those of you who don't know what we're talking about, that's okay. MetaMask doesn't show this information anyways, which I don't love. But we'll get to that in a bit. Maybe this will take 3 hours. Let me finish this, and we'll take a 10 minute 10-15 minute break. But in any case, now that we've but keep that thought. Keep that thought, because the type hash will come up shortly. But no, the data that we saw is the approval data for the transaction. But so now that we've signed it, we can now execute it. And once again, I could look through all the data in here, and I could say, yep, this all looks good, but I don't want to trust the safe UI. I want to trust my wallet, which again, the trust assumption there is my wallet is hacked. My wallet is not hacked, but my wallet is easier to be safe than the safe UI. So if I'm happy with this, I can now send it. And now this is going to be a classic transaction, right? So now this is a transaction request, not a signature request. So when I copy the data and I paste it in here, now I get kind of the classic hex data. And so if I pull up my terminal, now I can do cast calldata decode. And this is where I would put in the signature for exec transaction. I put this signature in. This is like a lot. I would need to do address, 256 bytes, all this stuff. I have a little shortcut that I use that automatically does all that for me. MSC, paste in the call data, hit enter, and now I can see all the decoded parameters in here very easily. So we see the 2, We see the value. We see the data. We see all these zeros. And then at the bottom, we see the signatures, which this is the signature that we just signed in that last section. And then I would, of course, verify all this looks good, like a normal transaction. And it does. So then I would go back to my MetaMask. I would say, yep. Oh, and then once again, MetaMask actually does decode it already for us, right? Exact transaction, all the different parameters. And I'll hit confirm. And then it'll send the transaction. MSC is my shorthand for multi-sig, multi-sig call data decode. It's like an alias that I use because I decode multi-sig transactions relatively often. Now, before we take the break, I want to show you one more real quick thing. Transaction builder, WETH, paste it in, give me the ABI contract or code. Copy this. Paste it in here. Copy this again. Paste this in. Let's say 0. Add new transaction. Create batch. Send batch. If I were to hit yes, execute, and execute, what's going to pop up is only the transaction data. But here's what is super frustrating. Parameter 10 should be the signatures, right? Remember last time it was 2 steps, right? We signed it, then we executed it, and then I kind of glossed over it, but we showed that parameter 10 was the signatures that we just signed. Now, it's different. It's actually you can't see it. It's actually a placeholder with our address. It's not the actual signature. So here's what I don't like at all. When we do sign and execute, our MetaMask tries to be clever and just has this placeholder here and says, oh yeah, like you'll sign the data and send it over. We don't actually get to see what we sign. We don't actually get to see what our signature is. This is bad because what could be done was the website could send a malicious signature, which even if everything here looks good, it would break this and we'd be like, oh, that's weird. Let me just run this again. And we'd rerun it. Wait, this is a different. What am I calling? 4byte. Oh, I am calling approve. Oh, that's super weird formatting. I hate that. But fine, whatever. So typically, we never want to do this. We never want to do sign and execute. We always want to sign first and then execute after. Because if we do sign and execute, MetaMask and most hardware wallets too won't show you what you're signing. So we want to do no later. We hit sign, and then it'll show us, okay, here's what you're signing, classic signature. So we never want to do sign and execute. We always want to sign first and then execute. Okay, any questions on all this before we take a break? I'll give everyone like 10 minutes to digest and ask questions. Actually, yeah, let's start the break now. And we'll just we'll restart. I'll start the next section at 2:38, so in literally 10 minutes. So we'll do 10 minutes of questions, or if you want to like go to the bathroom, grab some food or something, or ask questions. Great. Saeed, can I like highlight comments or something? No. Oh, whoops. You mean you set MSC as an alias for the cast call data decode rest of the command? Yes, exactly. I have a lot of aliases for stuff like that because rewriting all of that is annoying, right? So like the actual command would be like cast call data decode exec transaction, and then like address UN256 bytes, maybe like UN250, blah, 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 a whole bunch of stuff, and I can't be bothered to type that out every time. So great question. Other questions? Multi-signature cast, I believe. Yep. Yeah. Multi-sig cast, or I call it. In my brain, I had it as an acronym for multi-sig, call data decode, but same thing. MetaMask front end dev should stop vibe coding and fix this. See, like the thing is, it's not. This is actually a great point. It's not super dire because I can go through. So like they give me all the information that I am signing, right? They give me the safety TX struct, and I can verify all the parameters. It would just be easier if they just gave me that hash. And if they fuck something up on their side and they give me like the wrong domain hash or something like that, I would be able to see that. Right now, I am kind of trusting that MetaMask isn't fucking that up, which is a bit spooky. Actually, all hardware wallets, except for my testing, it seems like Ledger might be the only one that will show you like the domain hash and message hash as of today. Because I just spent like 12 hours yesterday like ripping through hardware wallets to test this. Those two might be the only wallets that as of today show you the domain hash and the message hash. Most of them don't, which is not great. So param3 function selector can't be identified. Maybe it's MetaMask causing the issue. What do you mean param3? What are you talking about? How did you learn all these without Cyfrin Updraft? Yeah. I spend a lot of time, reading documentation. The hardest part was AI didn't know any of this shit. You know what I mean? Like that was the hardest part. It's getting better because we've written a lot of information about it now. But you said we should never use underscore while building a CLI command. Any specific reason? Yeah, it's hard to type, so you have to do shift. You have to hit the shift key, and that's annoying. You don't want to have people hit the shift key to type characters in your CLI. Like it should just be like all lowercase, no shift weirdness. That's it. Straight 12 hours? No, I went to the gym. I like ate food. It wasn't straight 12 hours. The hex code you couldn't identify just now in the MetaMask modal. Oh yeah, when I hit sign, yeah, it's super weird. I don't know if that was like a really weird bug that I saw. Because like, yeah, looking at it now, it's like this is correct. The reason it jumped out to me because I didn't see the 0 here. But maybe it's not a bug, maybe it's fine. But that was really odd, I'd never seen because I see this and my brain goes, oh yeah, that's the approved function selector. But I didn't see the 0 here, I'm pretty sure, right? Like, am I crazy? I mean, we can go back and look at the recording. Yeah, I didn't see the 0 here, right? 1, 2, 3, 4, 5, 6, 7, 8. I guess it doesn't matter because it's just like assumed that the 0 is there. I guess that's fine. I've never seen it not have the 0 there. I don't know. Weird. One of your Cypher Uptrap boys should have represented ETH Denver. I spent a lot of time chilling. Hey, I appreciate that. I appreciate that. ETH Denver. I feel like it's a little bit less developer-y these days, but maybe. I mean, I'd rather people go to like Python conferences and chill, eat Denver, or like JavaScript, or not chilly, or like JavaScript conferences and chill Cyfrin Updraft, right? Really want to get those people over here. I appreciate you for shilling that though. Yeah, so we'll take 4 or 5 minutes for more questions. Have people take potty breaks. Is all of this making sense, or are people still lost? Starting to make sense. Okay, makes sense. It might not settle. The pace is good. Okay, I'm trying to like make sure like to like kind of re-go over stuff, and yeah. What's nice is we went from 100 to 48, so now it's like kind of a more of a tight knit group, which is cool. The people who dropped off are the people who are going to sign a $1.4 billion transaction and lose all their money. So, uh, Equius, we should take a screenshot of like the people who started and the people who ended, and then just like follow the people who dropped off and be like, oh, I see you all signed malicious transactions. Whoopsie daisy. That's what? No, I'm kidding. I'm kidding. Don't put them on blast. I'm joking. Don't do that. I'm joking. I'm joking. I'm joking. I'm 100% bad joke. Bad joke. It's definitely a bad joke. Bad joke. Do not. Yeah. It's definitely not our style. Because yeah, people have stuff to do. People have stuff to do, and this is being recorded, which is good too. And a lot of this information is already on Cyfrin Updraft. So helps paint the picture. Okay, pace is good. I did the hackathon. I ate up so much time that I didn't really see the main events. I love that. Whenever I went, when I was first starting coding, I just showed up to like drink energy drinks and like code. Like that's it for hackathons. We got a couple more things to show you, and then I can send you on your way. I think the problem is always going to be convenience, man. The average person will put themselves through hell. They have a tiny bit of work. This needs to be part of the process to instead of an extra one. How do we get there? It's a good question. I'm gonna try to get to that a little bit too. We go through 5 billion hacks in a month, and people will still get lazy. Yeah, we're thinking of turning this into a certification, because if you're in charge of, even if you're in charge of just like less than $1 million, even if you're in charge of like 50 grand, you should really know what you're signing. And once you get fast at this, like, because I literally, I go through, I'm on multiple security councils, I sign transactions all the time. You get really fast at doing this. Like it doesn't take, like, once you get in the zone, like once you get into the flow, it doesn't take that long to do this, to just add this verification step. So enjoying the call so far. Okay, cool. I feel like because we went from 100 people to 50 people, I'm doing a bad job. I'm like rambling on, but I appreciate you all being on here for the this trial run. Hopefully, you're all learning a lot. Okay, cool. It's time to be back. So let's flip back over. And I told you guys I was going to have you all So for those of you who stayed, have you all actually do this yourselves, and we're going to get to that very shortly. So um, cool. So what's next? Well, I still want to get to hardware wallets, but somebody talked about convenience. So we showed that tool, the safe hashes tool, to kind of get the safe TX hash, domain hash, and message hash, which MetaMask didn't show us anyways, which was super annoying. Yes, Susan, this should be recorded. But there's another tool, one that the Open Zeppelin team gave us, which is awesome, called safeutils.openzeppelin.com. This is a website that will also compute these message hashes for you. However, once again, if you use this website, there's a trust assumption that this is correct. So it would be better if you downloaded our tool, use that on an isolated device, and use that to get hashes. But what you do is basically kind of the same thing as the tool. Put in chain ID, your safe address, your nunts. So for our nunts1, safe version. Ours is 1.4.1, but it actually doesn't matter. 1.4.1 and 1.3.0 have the same type hash. Recipient address, aka the 2. Normally, you wouldn't want to copy off the UI because you don't want to trust this UI, but I'm going to do it because I don't care, because it's just like a demo. Like normally, you'd copy it out of your wallet, or you'd like go directly to the address to make sure it's what you want. Recipient address, value, transaction data. This is where you would like do it yourself. So like, I would say, okay, what do I expect? Cast call data. I'm calling approve. Address, Unit 256. The address I'm calling approve on, I think it's this one. No, it's this one. Yeah. This one and 0 gives me this call data. So I can copy the call data, paste it in here. So I want it to be a call. I'm going to hit continue. All the zeros here look fine. And I would hit calculate hash. And it would give me the safe TX hash, domain hash, message hash. We can double check those are the same as what's on the UI here. The safe TX hash is kind of the combination of these two. So for now, I'm actually just going to check that one. And I see that they're the same. So that's really good to see, right? Just check what you're pasting. Yeah, exactly. So, and then if your computer has like a copy paste malware, like you're screwed, right? This is another reason why it might be a good idea to have different devices. Anyways, I'll hit sign, and this is where I would love MetaMask to show that safe hash, because that at least I could like really quickly check. Since it's not there, I do have to kind of manually check all these parameters here, which is annoying, but fine, whatever, not the end of the world. And I'm also trusting MetaMask isn't screwing up like the calculation of the domain hash and message hash and blah, blah, blah. So hopefully in a future version of MetaMask, they actually update this. What is nice about MetaMask is they do decode it for you. Like Rabby Wallet and other wallets that I were testing don't do that yet. So cool. Now the final thing I want to show you all before I give you a chance to try this yourself is I'm going to show you all this on a hardware wallet. So why do we want to use hardware wallets instead of like MetaMask software wallets? So can somebody tell me in the chat while I add this hardware wallet why we'd want to use a hardware wallet instead of a software wallet? Okay, I'm seeing A lot of different stuff here. So, because it's a cold wallet, so this is actually one of my favorite things to talk about. So let me ask a different question. What is a cold wallet versus what is a hot wallet? So people say you should use a hardware wallet because it's a cold wallet. What is a cold wallet? What is a cold wallet? Somebody tell me. Tell me what's a cold wallet. Isn't a cold wallet offline wallet? Hot wallet is browser based only. Cold wallet is a wallet that's not connected to the internet. Okay, so kind of. It looks like you're just about there. But let me ask you this: when you connect your hardware wallet to the Safe UI, is it still a cold wallet? You didn't think about this, what did you? No, no, no. A lot of people are saying no. Okay, so then let me ask you this: is a hardware wallet a cold wallet? Somebody said yes. Okay, cool, love it. Okay, so is the hardware wallet a cold? Okay, so I feel like I just mind destroyed you all, right? You all just said no, hardware wallets aren't cold wallets. You all just said, hey, when I connect my hardware wallet to the internet, is it a hardware wallet? You all said no. Excuse me. I just said, when I connect my hardware wallet to the Safe UI, is it a cold wallet? You all said no, it's not a cold wallet. And then I said, okay, well, is a hardware wallet a cold wallet? And you said yes. That doesn't make any sense. It's still a cold wallet even when connected. I love this. So this shows that the industry doesn't know what the hell a cold wallet is or a hot wallet is, because the definition has been very vague. I'm going to tell you what the Cyfrin definition is, and this is what I think the definition should be everywhere because I think it's actually very confusing. A cold wallet is a wallet that is not connected to the internet. A hot wallet is a wallet that is connected to the internet. When I connect my Ledger device or my hardware wallet to the Safe UI, it is no longer a cold wallet. It is a hot wallet. It is connected to the internet. That is my definition. So if your device gets, so if you're saying, hey, I'm using my hardware wallet, I'm using my cold wallet, I would say, what do you mean? What do you mean? How do you send transactions then? Huh? What you never, how are you sending transactions without being connected to the internet? Huh? What? It signs the transactions offline. If it signs the transactions offline, and then you send it to a physical device, a different physical device, and then manually grab the signatures and put it into the internet, then great. Then it truly is a cold wallet. But I'm going to argue that a lot of your definitions of cold wallets are not correct, because when you connect your wallet to your computer to the internet, it is no longer a cold wallet. So the private key isn't stored online. That's not true either, because your MetaMask, your private key is not stored online either. Your MetaMask, your private key is stored in your browser. So hot wallet, your wallet is connected to the internet. Cold wallet, is it cold when you disconnect it again, or is it tainted forever? I would argue when it is disconnected, it is a cold wallet. When it's connected, it's a hot wallet. You could argue, yeah, it could be like a binary. Oh, like if you ever connect to the internet, like it's a hot wallet, it's cold wallet. I just think if it's disconnected, it's cold. If it's connected, it's hot. That's how I think about it. And it can switch between being hot and cold. So the Bybit wallet, they called it their cold wallet. It was a multi-sig. And that's like kind of more interesting because it's like a smart contract and it's like on the blockchain. But I would argue that a multi-sig contract is a cold wallet, because it is actually never connected directly to the internet, because it's just like amalgamous code. But that's I don't know. Now we're getting to weird philosophical arguments. Now I've opened up a box of worms about wallets, haven't I? You know what I mean? I didn't mean to get into this box of worms here. I'm sorry I did this to you all. We can go over fighting about whether or not it's a hot or cold wallet like another day. Anyways. Okay. So what we're gonna do, um, it's just it is something that I want you all to think about though. Like when you're using these terms, what do you actually mean? What is a hot wallet? What is a cold wallet? I guarantee you, if you drill into it, a lot of people don't know what the hell they're talking about, and that's okay. And that's okay. But it is important that we say, okay, like a lot of people will blanket say cold wallets are better than hard wallets, or excuse me, cold wallets are better than hot wallets. My hardware wallet is a cold wallet, but I connect it to the internet to send transactions. You know, like what are your trust assumptions, right? Um, anyways, I want to show you what this transaction looks like on a ledger device. I'm using a ledger because the ledger is actually going to show us the domain hash and the message hash, which you combine those together, you get the safe TX message hash, which is like going to be the quickest way to verify these multi-sig transactions are good, which is why I wish all wallets did this. So I've just added a signer here. We can do another new transaction here. Transaction builder. Let's leave that open. And this is kind of the crux of what we're doing here. So now we're going to do the exact same thing. We're going to approve. We're going to call the approve function. We're going to approve 0 on just itself, which is like kind of a stupid transaction, but whatever. But we're going to do this on the hardware wallet side. And that means I need to disconnect. I need to reconnect with my, okay, let's edit. Let's go to ledger 2. Let's update. So the reason I'm connected through my MetaMask like this is because the Safe website recently removed access to like connect the Safe website directly to your ledger. And so what I've done is I've actually set my MetaMask up to be kind of a proxy between the Safe UI and my ledger. So my MetaMask will pop up to say, hey, do you want to confirm this transaction? But it'll send everything to my ledger device, and I have to confirm on my ledger device. Why am I using ledger? No form of endorsement here. I have a Keystone with me. I have a Trezor with me. I have a Grid Lattice Plus with me. I have a Tangent wallet with me. I have a shit ton of wallets on my desk. The reason I'm using Ledger for this demo is because Ledger at the time shows you the domain hash and the message hash, which is something I wish all wallets would do. So, but I have a deep dive on like hardware wallets coming up soon because I just spent a gratuitous amount of time. But anyways, so I've set up my MetaMask to be a proxy for my Ledger. There are some docs on how to do this. It's actually pretty straightforward on how to like connect your MetaMask to your hardware wallets. So I'm going to update. I'm going to connect. Great. Now I'm going to do add transact. And now you can see this is the address of my ledger. This is correct. I've checked it myself. Add transaction. Now create batch. Send batch. And we're going to do the exact same thing, right? Would you like to execute this transaction immediately? No. Why not? Somebody tell me why I should not execute this transaction immediately. I taught you this maybe 30 minutes ago. Why should I not execute this immediately? So you can verify the signature first, correct? Yes. Because if I hit execute, it's not going to show me what I'm signing. I would like to see what I'm signing. I would love it if wallets, if I hit this, if wallets showed you what you're signing, but they currently do not, which is super freaking frustrating. So let's verify what we're signing. So remember, it's 2 steps. What are the 2 steps? Sign the transaction and then execute the transaction. 2 steps. We want to verify the signature and then we want to verify the transaction call data. 2 steps. Remember, verify the signature, verify the call data. Verify the signature, verify the call data. So let's do those 2 steps. Let's verify the signature, sign. Now, My MetaMask pops up, says, hey, you're connected to your ledger. Be sure your ledger is connected. Oh my God. And it keeps freaking disconnecting on me because it hates me. Enable this stuff, blah, blah, blah. And I get all the same data that I've seen before. So my question is, now that my ledger is the wallet, can I trust what is in my MetaMask? Can I do the same process? Right? Because what did we do before? Okay, we verified the two, we verified the data, we read all this stuff in here. Can I do the same thing? I'll just verify all this stuff, and if this all looks good on my MetaMask, I'll just confirm it on my ledger. Can I do that? The exact same process that we just did. We still have to verify. Verify what? Yeah. The data we're signing. Verify, but I see it right here. I see the data right here. Can I just verify the data here? I see all the data here. If it's the same thing on the ledger, what's the issue? Has to match your ledger, must verify the ledger, verify what MetaMask is doing in the ledger. Exactly. Beautiful. Oh, you're all so freaking smart. Now, the source of truth wallet is my ledger. It is no longer my MetaMask because we always want to verify the data on the device that is actually doing the signing. Before, our MetaMask was doing the signing. So our MetaMask was the source of truth. Our MetaMask was the data we needed to verify. Now, since MetaMask is just sending the request to my ledger, if my MetaMask is hacked, it could send bad data to my ledger, but show good data on the UI. You always want to verify the data on the device that is doing the signing. Since MetaMask is no longer doing the signing, and the ledger is doing the signing, we have to verify the data on the ledger. You are all wizards. You're all going to be able to sign transactions that save you $1.5 billion. So I'm going to hit confirm. And it failed because ledger like locks every like 2 freaking seconds. So, and this is one of my test ledgers. Because I have like 100 of these and I guess I don't remember my PIN. Oh my God. This is one of the fun parts of working with hardware wallets is when they bug out on you a little bit, which is like kind of terrifying, but such is life. Okay, cool. Let's resign. Yeah. Okay. And now it's going to show up on my ledger device, and I'm going to try to get real close to the camera, show you what we're seeing. So on ledger, can't see it because it's kind of like, come on. Oh, can't focus on it. It just wants to stay focused on me. That's so. Oh, there we go. Okay. Well, you can't really see it, but it says blind signing. Should have used one of my other ledgers, huh? Maybe I can use this ledger. Hold on one second. That was the ledger Nano. I also have a ledger Stacks, which actually might be easier to see. I have to do. Sorry, one second here. Uh, Here we go. To reconnect. Yeah, my goodness. This is my test MetaMask, so I don't really care. But I have to repopulate this. I do want to show you what shows up on the device, so I'm switching to a different ledger. Sorry about that. I had to restart my browser because MetaMask currently has a bug where if you do what I just did, it freaks out and like crashes. Okay, let's sign now. Sorry, I got a little bit of the snuffles here. And we'll confirm, and it should go to my ledger, and it sure freaking does. Okay, so now we're gonna use the ledger stacks, or the ledger flex. So, excuse me. Wow, this one's still blurry too. Okay, well, I guess that's good enough. It says blind signing ahead. This is basically like Ledger's way of saying, hey, um, God, it just disconnected on me because it frustrating. Oh my God. Okay, so maybe I'm not going to show you because if it keeps disconnecting on me and I have to keep redoing this, I'm going to lose my mind. And it just disconnected on me. All right, hopefully I'll show you the at least the domain hash and message hash like super quickly. Okay, so I just had to redo everything. Sorry about that. It says blind signing ahead. Details of this transaction message are not fully visible. So according to Ledger, I don't really love their definitions here, but blind signing is just when you sign data that isn't decoded, I guess. Whereas clear signing, according to Ledger, is when data is decoded. I don't know why they created kind of their own terminology for this. I don't really love the terminology. But whatever. On my Ledger device, I'm going to say continue anyways. And it says reviewed type message. And on here, what I actually love is it gives you the EIP 712 domain struct. Hopefully you can see this and hopefully it doesn't disconnect on me. So it gives me the chain ID and the verifying contract. That is stuff that is used to create the domain hash and the message hash. And those are two pieces of information that do need to be correct so that you don't do replay attacks on different chains. So this is something that somebody messaged, hey, like what about replay attacks? So this is actually to prevent against those type of replay attacks. Then it allows me to review the struct. So like that stuff that we saw in MetaMask where it said like to value, data, blah, blah, all that stuff. It allows me to review, and I'm reviewing that right now. One of the things I kind of hate about hardware wallets is they go, oh yeah, here's the call data. Here you go. Does that look right to you? And right now, if like the question is, okay, like, you know, I can verify this on my computer, but like pulling this off the device to like actually compare is kind of challenging right now. There's a couple ways to do it. Some people, what they'll do is they'll take a photo of their hardware device, send the photo to their computer, and then like AI is usually pretty good at like pulling the text out of the photo so you can verify the call data matches what you expect. what the Keystone wallet does that I think is really cool is it actually generates a QR code that you can scan to get all the data. I would love it if more wallets did that. I think that that's a really good one because right now, like they're like here's the data, and what did they expect to like spot check the data? I mean, luckily this is an approve, so it's like pretty small. But if this was a bigger transaction, like what are you just screwed? Anyways, I hit next. Gives me like operation, safe TX gas, base gas, the same stuff we saw in MetaMask. Gas token fund receiver, nonce. And then it says accept risk and sign type message. And this is a bug with Ledger at the moment. It's not showing me, like this is technically enough information that I can feel happy to sign if the data looks correct. I'm going to reject it because what it'll then do is it'll pop up again and say, hey, blind signing ahead. It's like, oh, wait, what? I just rejected. What am I signing now? And now it'll show you the domain hash and the message hash, which these are the values that we calculated using that tool. Sorry about that. Oh, it's because I deleted everything. Sorry about that. There we go. Much better. Yeah, you saw my OBS setup. Damn. We calculate with this hash or with this with this tool here, or when we did the safe hashes tool, right? Safe hashes dash network, network, blah blah blah, all that stuff, right? So this actually will give us the domain hash and the message hash, and I wish all wallets did this. I just wish they did this in the same prompt instead of like me hitting reject and then it like gives me the hash. Like I don't know. That's like super bizarre. What's also frustrating is if I accept this one or the one I just rejected, it'll send it either way. I don't know. I think that's definitely a bug, but whatever. So now I'm holding it to sign it. Message signed. I just signed on my ledger and immediately went through back to my MetaMask to send it. So now, if I go to transactions, I have this that I just signed. And once again, I can now execute it in a separate transaction. I don't really care what MetaMask tells me because I'm verifying on my device anyways. On my device, once again, I get review transaction. And now I can review it like I review like any other transaction, right? So it'll give me the from, the transaction hash, right? Exactly the same stuff that we'd see in our MetaMask, because now we're verifying the transaction. Obviously, what we want to verify is like the network, and the call data. And what's frustrating is for the ledger, I actually have to reject this one because I have to go to the settings and I have to turn on debug smart contracts, which will show the call data. But for some reason, Ledger just calls it debug smart contracts, and it shows it in this like really horrible format, which I don't want to show you guys. Ledger, please fix. Actually, no, I will show you because it is like really bizarre. So, and every hard wallet has their pros and cons. The pro of the ledgers is that they do show the domain hash and the message hash. Not a lot of other wallets do that, which is great. The cons are what I'll show you in a second. So to view the call data, it chunks up the call data into bytes 32s. It just takes the whole call data, chunks it up into bytes 32, and it says, "Hey, here's field 1. Does this look good to you?" And it shows you in this like weird format. Sorry, I'm like putting Ledger on blast a little bit here. And it says, "Hey, like, do you approve field 1?" I guess they're like assuming all parameters are exactly 32 bytes long, which isn't the case. and you have to like confirm each bytes 32. So for example, like we know parameter 3 is a bytes object, but they're showing kind of the raw call data for parameter 3, which is this, which is like, what the hell? But in any case, I'm going to hit reject because I don't feel like going through 18 fields of that stuff. But yeah, verifying call data on your hardware devices is hard. Ideally, it just shows you like a QR code. You can scan it, pop it into your CAS tool or something like that, etc. So I have some wish lists for different hardware devices. But good thing that Ledger does, they show the message hash and the domain hash for signatures, which is very good. So, and then I would execute it obviously normally if I went ahead and accepted it, but I didn't. So, does that make sense? Are there questions with any of that? I missed the chat. Are there any questions with any of that? What is blind signing? Is that a technical term? Oh, sorry. No. Blind signing is a term that Ledger came up with, and it means just signing a transaction without decoding the call data. Now, I actually don't even love that, because if I have a transaction that takes bytes as an input, and then it will encode those bytes to send another transaction, like if you decode the transaction, basically you can have nested transactions, right? And you could say, oh, it's clear signed. Look, I decoded my my first layer of transactions. But if you have a transaction that takes bytes, hopefully that's making sense. You can have transactions inside of transactions that need to be decoded. So blind signing is kind of Ledger's term for like signing transactions that aren't, where the call data isn't decoded. Blind signing in the context of hardware wallets refers to practice of approving transaction without being to visually verify its details. So this can occur when using hardware wallets that lack screens or when blah blah. So actually, the definition Ledger gives and what the setting actually do are different, which is again why I hate the term, because it is same thing as hot wallets and cold wallets. It's very confusing. I'm glad you're all asking here, sorry, I have streamer mode. I can't actually see your name, but S, the woman with whose username starts with S, in the chat. Thank you for posting that. And that's probably what Ledger's definition is, and I think Ledger's definition is wrong, even for their device, because when I turn blind signing on, I can still verify on the device all the data that I need, right? I can still see it all. What it doesn't do is it doesn't decode the call data. So for me, blind signing is signing a transaction where call data is not decoded, and that's known as clear signing. So I think, once again, I think Ledger and the community are being confusing with their definitions, and that's actually a huge disservice to everybody. I've kind of ranted about this before, but anyways. Hopefully that cleared it up. If it didn't, please ask in the chat. I'm reading the chat. You all are being fantastic. These are great questions, by the way. And then we're about to get to you actually verifying some stuff. I promise. I thought there's something to do with the colo. See, the trouble you're having, Patrick, that the security part. I like Keystone's idea of a QR code too. Yeah, the QR code stuff is actually really cool. So the Keystone actually even has like a little camera on it. So you can see the test, where it can scan QR codes and actually will show QR codes, and it's really nice. Hey, are you guys sending this recording to various hardware manufacturers? I've already DM'd many of them, and many of them have ignored me. How are you going to verify that with the CAS tool? Way too much conversion work. Yes, exactly. So right now, it's really frustrating to verify call data on your hardware wallets. It's like an issue in the industry. Like I said, there's a couple ways to do it. Some wallets will decode your call data, and that makes it a lot easier to do. Others like will give you like QR. More should give you a QR code. But right now, the way a lot of people are doing it is they literally like read all the call data on device, which is awful. Rooting for the Cyfrin hardware wallet by implementing all the missing features. The Cyfrin team is quite busy with a billion other things. We will not be making a hardware wallet. That's funny. I'm EE if need help. What's EE? Excuse me, I'm recovering from some sickness. Well, I didn't know there was such rudimentary issues. I can see how North Korean hackers were able to hoodwink the Bybit electrical engineer. Okay, yeah, exactly. Cool. Any other questions before I have you all do some signing? Does this not make sense? Who's completely lost? Who's completely lost? Who's following? Who feels like they know what to look for when signing a multi-sig transaction now? And who feels like they understand the challenges when signing a multi-sig transaction? Or who feels like they're just totally lost? And yes, I feel like I'm like exposing you to like how not ready the hardware wallet industry is for DeFi. All right, Susan, understanding challenges, need practice, and feeling a little lost. Okay, Susan, what are you lost with? What is what are you lost with? Admittedly, never did. Okay, great. Yep. Admittedly, I've never played with a multi-sig. Great, all good. What are the items to look out for? Yes. Okay. Great point. So, what are the items to look out for? So, let me consolidate this, and I should put this into a blog as well. So, the first thing, whenever you're sending a transaction, I have to repopulate it every time, which is super annoying. Yes. Prove. Sure. So, whenever you're sending a transaction, whenever you're sending a multi-sig transaction, first thing is first thing is always sign first, never sign and execute. If wallets reach a point where they show you what you're signing, then you can sign and execute. But as of today, they do not. So you just need to remember, you need to verify what you're signing. You need to verify what you're executing. How do you verify what you're signing? Let's flip back over to MetaMask being the default here. How do you verify what you're signing? Well, you can verify one of two things. Either the entire SafeTX struct, or the domain hash and message hash, or the SafeTX hash. Ideally, one of those because those are way easier. But if they are not given to you, you have to verify all of this data. You have to verify all of these parameters are correct. Is the 2 correct? Is the value correct? Is the data correct? Are all these correct? Everything. You have to verify everything. How do you verify the data is correct? Well, you need to decode the call data. Oops. How do we decode the call data? Well, we're going to run cast, call data decode. And this is assuming your foundry is not hacked. Cast call data decode, we're calling approve on an address, U256. This is the call data that was given. So this means we're calling approve on this address for this amount. That is what I want to do. I want to call approve on this address with this amount. So I verified the data of my signature looks correct. And then all of these look correct as well, especially operation. If this is anything other than a 0, we should be a little concerned. Since I'm using my MetaMask as my source of truth here. I'm now good to hit confirm. However, if I was using a hardware wallet, I would need to confirm all the data on the hardware wallet. You'll want to confirm the data on whatever device that you're signing. So these are the bullet points that we can put in a blog to summarize this. Now that I've confirmed all the data here, I've confirmed my signature, I hit confirm. My MetaMask will sign it. Now I can view the transaction. Now in a separate step, I will execute this. And I'm going to verify the execute as a regular transaction, right? Once again, I want to verify the call data now instead of the signature. For verifying transactions, all you do is verify the call data. MetaMask goes ahead and decodes the call data for me here. You can see param number 10 is our signature, which is now actually filled out with like a real value because we signed it first. If I don't trust MetaMask's decoding capabilities, I can copy the data myself. I can go to paste it in here. I can see this is the exact call data that we're calling. And I can do cast call data decode exec transaction, because on a multi-sig wallet, this is where you're calling, all the parameters. I have a shortcut called MSC, paste it in, and now I can see all the decoded parameters. So I'm sending to this address value of 0 ETH. Here is the actual data that I'm sending, and I could once again decode this call data, and this is what I'm talking about, like nested transactions. I could do cast, once again, call data decode. This should be the approved transaction with an address and EU into 256. And I see I'm sending to here with this amount. So I'm approving this address for 0. So great, the call data looks good. All these parameters look good. And then this is the signature. So that's just me verifying a regular transaction, and I hit confirm, and now it's going to go through. So a lot of steps here, and I know it's a lot of steps. It's a lot of verification, but especially a lot of time, like if I'm playing around on Sepolia, like I don't go through this because like I don't care if my transaction's wrong. But if I'm sending a real transaction with money, or if I'm sending a transaction on a security council for security, you damn well sure I'm like checking all this stuff. So yeah, good shout. We should put this in a blog. All these little bullet points. Susan? Does that summarize it pretty well? Recap. Yes. Ah, that is beautiful. Thank you, S. That recap is phenomenal. That was a beautiful recap. Okay, great. Cool. Oh, now we have to worry that Foundry has also been tampered with. Yeah, so when I say the Foundry bit, you just always want to know what your security assumptions are. Since I'm using Foundry to decode my call data, if Foundry gets hacked, it could be decoding my call data wrong. This is actually why it's good that we have multiple different ways to do it. So for example, like this site is another way to do it. There's different tools out there, which is good. We want there to be different tools because we want there to be, redundant ways to verify our call data. Need to talk to, maybe we talk to Georgios, huh? No, I'm just kidding. Can we improve the logs for the CLI? I mean, more readable? Yeah, we could. Yeah. Or if you want to make your own call data decoding tool, you can do that. Okay. So with all that being said, here's what we can do now. I can have you all do some verification yourself. If you have Anvil installed, and many of you do, Anvil comes packed with a lot of kind of dummy private keys and dummy accounts. Account 9 or 10, if you're one indexing like a lunatic, is currently one of the signers of this multi-sig. Let me send this to you all here. So what you can do is you can go to your MetaMask and go to accounts, add hardware account, import account, and paste the private key, this one down here, into your MetaMask. And you, my friends, can do some verification yourself. So what I want you to do, and before you all do that, I'm actually going to change the number of centers to 2. And I'm going to hit execute, which you should never do, but I'm on a test net and I don't really care. So like I would 100% want to verify this, but I'm on a test net and I don't care. This is fake money, so like whatever. But normally, yeah, especially for sensitive actions like changing the number of signers, you want to verify. What we can do now is if you want to come in and you want to sign one of these, you can. Now if I do a little refresh here, it's now a 2 out of 3. Or it should be a 2 out of 3. And I'm going to create a new transaction in here. Paste this in. Oh, I'm supposed to be hiding this, right? That's right. And we're going to have you verify a signature, a transaction that I make. So if you log in now to the Safe website with this, oh, I don't have it in here. Let me do that. Take the private key. We'll do add account, import account. Paste it in. We go to transactions here. Oh, let me disconnect. Or let me change to account 2, which is our Anvil 10. I can now confirm this. And you should be able to pop this into your MetaMasks as well. It's just the number 9 here, the private key. That's this address here. I can now confirm this. I go to this page. Don't look at any of the data here. And I could decide to sign it. I could decide to execute it. I can do whatever I want here. I would like you to verify that the signature here is correct. What the hell is this? That looks wrong. And I'm going to tell you what we're trying to do is we're trying to call approve on the Sepolia WETH contract for 0. So please verify that it is correct or incorrect. Once you're finished verifying it, paste in the chat what you think the answer is. If it's valid or invalid and why. Valid or invalid and why. And I'll give you some time to do this. And if you have a hard time getting to this page, let me know. Sorry, I keep coughing. So yeah, so take some time. Can you share the available commands? What do you mean? What available commands? Yinkzo Ko, I don't know how to say your name, sorry. It is, the fee is a Sepolia fee. The cast commands. So it'd be cast. Check the data object in the transaction data. Actually, we're showing on screen some cheat codes. Whoops, sorry. Should this have been a approval for 0? So you are verifying whether or not this is correct. So I see some people thinking they figured it out. It's approving one way instead of 0. So we have the TX builder to approve a TX on the WETH contract and then decode the call data. No, so you don't have to use the transaction builder. So the transaction has already been proposed. So this is basically like somebody on your team says, hey, buddy, propose this transaction in our multi-sig. It's a 2 or 3 multi-sig. Can you sign this, please? Can you sign and execute this, please? And you got to go, well, what are we trying to do? And they say, hey, I'm trying to approve 0 way on the WETH contract. And you go, okay, cool. Let me verify that that's actually what that's doing. You don't have to use the transaction builder. Where is the file to see the exact transaction parameters? What do you mean? Might as well practice if I can. All right. Well, so Saeed just put in the put in one of the answers. Yeah. So we're approving one way instead of 0 way, and that was how it was done. So I want to give some other people some more time to try to reach this point as well. Because maybe you're wrong. Maybe they find something else. So Saeed's saying, hey, we should not sign this. And what Saeed just did, if he is correct, would have protected Bybit, by the way, from $1.5 billion loss. Hey, the call data is wrong. Actually, that's not true. He would have needed to check the safe hash, the signature. But I digress. Should put a timer up. Yeah, I guess I should. I can't see any call data in my MetaMask. Is it possible I have an older version? What do you see? You want to send a screenshot of what you see? Chris thinks it's not safe to sign. Why does Chris think it's not safe to sign? I'm not allowed to send screenshot. Oh yeah, that makes sense. Can you copy paste what you see or like type out what you see? Oh, Equius giving people permissions. And this is great. If you've never worked with a multi-sig before, like this is awesome getting this experience now. Aha. Yeah. Okay. So you don't see anything. So you're seeing a transaction request. So first off, why are you seeing a transaction request? Is that right? So we have to decode that. Ah, but are you decoding it? Where are you decoding it? Are you decoding it from the Safe UI? Oh, wait, hold up. There might be an issue with the Safe UI. This is why we need competitions. Here, this is why we need competitive tools. Oh, sorry, gang. I uh I replaced that transaction with this one. Sorry. I think there was an issue with the last one. Or wait, not this one. Sorry. This one. Apologies all. Use this one instead. I think the safe UI bugged out on the last one. Sorry about that. Don't you love to say the safe UI, huh? Oh, it's super bugging out actually. Sorry about this, gang. Works for you? So Ellamore posted that it's requesting a transaction for them, and it's requesting a transaction for me as well, which is wrong. I click sign, but I keep getting TX requests. Yeah, so that's what I'm getting now too, and that is the website bugging out for sure. Um, that's super bizarre. Oh my god, did they? Yeah, it shouldn't be. That's a bug. All right, well that's annoying. Okay, so maybe you're not going to get to use the safe transaction wallet or the multi-sig wallet. Yeah, it looks like it's bugged right now on Sepolio for some reason. But this is still good. I mean, if you see something bizarre and weird like that, that's a cue to like not sign anything. Anything that looks off or weird, you say, okay, that's wrong. I'm not signing. I'm not touching that. Um, Yeah, it shouldn't be asking you to send a transaction. It should be prompting you to sign this struct. I'm gonna see if there's something else weird going on. Maybe it recognizes that as an anvil key or something. I mean, that would be pretty impressive. Let me just check that. Wow. Sorry about that, gang. It looks like it recognizes that as an anvil key or as like a fake key. That's crazy, actually. Oh, I didn't realize that. Sorry about that, gang. Wow, that's actually so cool. But even with this, I decode it and got the correct hash, I think. Did you? Show a screenshot of what you got. All right, sorry about that, gang. It looks like it doesn't let you do that. That's actually crazy. It like knows that that's a known address. Huh. So I can't even add Anvil 1? What if I add Anvil 1? Let me try to do Anvil 1, sorry. I'm going to reject that other transaction. We'll see if we can do, see if Anvil 1 works. Fun time here. I have to like switch back and forth between all these wallets that I'm demoing. Okay. So now we're going to try Anvil 1. I just added this as a signer instead. Oh, lol, I canceled the other transaction. Oh my god, it's so annoying. So I have to make another transaction. Okay. Well, this is some of the beauty of dealing with multi-sigs, though. Get to deal with all this this fun stuff. That's good, though. I mean, when you get a bigger team, it is safer to have like multiple redundancies to really make sure that you don't screw anything up bad. So try this one more time. And if this doesn't work, then the safe UI is just smart enough to know that those are all Anvil accounts and they shouldn't be trusted. So, but let's try this now. So I just made another new transaction. I took Anvil 2 off, added Anvil 1. So here's the transaction now. And same thing if you go to MetaMask, account, import account, import account. in Anvil, we can take private key, paste it in here. And now we have Anvil 1. And I'm going to hit this little thing, edit which account is connected. Anvil 1 is going to be connected now. Now if I go to confirm, let's see if I get that weird pop-up again. Oh, okay. For some reason, this one actually works. Okay, so there's something bugged with that last one. I don't know what was going on. Something with that last address. I don't know. But in any case, try this one. So this one now, when you hit sign, MetaMask should actually pop up with the data for you to like try to decode and make sure it's correct. So, all right. Sorry about that, gang. Yeah, use Anvil or Anvil 0. I call it Anvil 1, but it's really Anvil 0. Here's the private key. And yeah. So now we'll take some time, go verify that. I mean, a lot of you pretty much got it. Yeah, I could swap it out with a random private key, but yeah, a lot of you pretty much got it. Where we approved one way instead of two, or instead of 0. But you really do want to make sure that you can do it in this, right? You understand how this works, so that you actually know what you're signing. And you verified all these parameters are what you want them to be, especially the data. So, right. So somebody asked, hey, how do you decode the call data? And some of you are doing that right now. So I'll give a, we're done in 6 minutes anyways. So yeah, if anyone has any questions about that process, feel free to ask. But yeah, we can also take the last 6 minutes here to have you actually verify this transaction yourselves. For those of you who have never worked with a multi-sig wallet, like now is a great time to actually start to familiarize yourself by at least verifying this. Like this will be your first step on a team with a multi-sig. Will be somebody will propose a transaction, then they'll send it to you and they'll say, hey, can you sign this? And this is where you, as the security-minded person, can say, yes, this looks good, or no, this looks horrible. Chris, perfect. Yeah, that is what you should see. I don't know what was bugged with the last one. That is what you should see, and that is what you need to verify. Spot on. I love that you're seeing that. That's great. Yes. So for this one, I actually did it right, which is wrong. I should have put one way. For this one, it's 0 way. Lol. Cast decode. Elamore, that is perfect. Yeah. So you got that in your MetaMask, right? And not the Safe UI. Perfect. Yeah. Well done. Excellent. Good job. But did you check all the other parameters? You check all these ones? I caught you. You didn't. I mean, you lucked out that's the only one I screwed up, but you have to check all the other ones. Okay, so this is good. I'm going to make some examples. Really appreciate you all going through this with me. Going to make some examples where I fuck with some of these other ones, and you have to verify it appropriately. And we use safe hashes to verify. No, yeah. So this is where um, I was a little bit unclear. That's a good question. So Domini asks, can we use safe hashes to verify? No. I'm still trying to reset my bash profile to 4.0. So okay. So for safe hashes, that tool is to verify the domain hash and message hash and safe TX hash. If you're using MetaMask, MetaMask doesn't show you any of that. MetaMask actually derives that information this from this struct that you see here. Um, so if you verify all this data is correct and you trust MetaMask is going to do the calculations correct, that also works. It would be better if MetaMask also showed that information, but MetaMask does not. Some wallets will, and that is much quicker to verify than having to like verify all this data. So we would prefer to be shown the SafeTX hash, domain hash, and or message hash. But as of today, most wallets do not, which is very frustrating. At the end of the day, what's the ideal criteria of trust assumptions? How much paranoid do we need to be? I mean, considering the worst case scenario where even the tools like ETHCAN and Foundry can be rigged too. So it's making me appreciate the concept of hashes even more. Exactly, right? Because if every single time you have to verify all this crap, especially if this data, I mean, we're lucky. This data object's really small. But imagine you call some crazy large function, verifying this is actually going to be very time consuming. So that's where, like, if it just shows you, oh, here's the safe transaction hash, or here's the main hash and message hash, that's way quicker to check than all of this stuff, right? And so that's why we would prefer to be shown the domain hash, message hash, and safe transaction hash because those are so much quicker. There's a real thing called security fatigue, where if you have to go through 1,000 hoops to do something, and maybe you don't appreciate all the hoops, you can reach a point where you're just like, oh, come on, get on with it already, or like skip things or cut corners because you're so sick of doing them. And that's actually a security issue. So you really want verifying this stuff to be as easy as possible. And that's where those hashes come into play. That makes it way easier to verify this stuff. And that's why it's better if more wallets adopt them. Because then you don't get that security fatigue, right? Because it's so much easier and quicker to verify what you're doing. So that's a great point. But Saeed, so your question, what's the ideal criteria of trust assumptions? So since we're technical folk, we want to have as minimal trust assumptions as possible. Now, in a production multi-sig environment, there are probably going to be people who are not technical signing things. Is this great? No. But as long as they can do basic verification, that's fine. Like if you teach them how to use, the Open Zeppelin site, the safe utils, that's great, right? That's already good enough. It's not good enough, but it's good. But at least one person on your team who signs should be, hey, Chris, well done. Yep, exactly. Well done. Exactly. Somebody on your team needs to actually know what the hell's going on under the hood when you're signing things. Somebody needs to be able to do this stuff. And for the person who is going to be in charge of that security and these trust assumptions, they need to know, well done, Chris. Spot on. They need to know what the trust assumptions are. So ideally, the trust assumptions are as minimal as possible, but you know what they are. So say that's like the critical thing. You know what the issues are. So, for example, when I see this in my MetaMask, if MetaMask is my signing wallet, what do I know? I know that I'm trusting MetaMask as my trust assumption. Hey, thanks, Hendred. We're just getting wrapped up here. I know MetaMask is my trust assumption. Since I know that, I know, okay, well, my MetaMask is a lot easier to hack than my hardware wallet. I should probably switch over to a hardware wallet, right? If I take this call data and I decode it with Foundry, I then know, okay, Foundry is another trust assumption or another dependency. And this is where it might be good for you to look at your team and say, okay, right now we're all decoding this call data with Foundry. Maybe we should have some people decode with Foundry, some people decode with something else, some people decode with something else. And that all just comes from knowing your trust assumptions or knowing your dependencies. If you think of like your team as like a software package, right? Uh, and you write out all the dependencies that your multi-sig um, transaction process depends on, you can find the things that more people depend on to be kind of the weak link, and maybe you want to mitigate that. Maybe you want to replace that tool with something else. So the question of saying, hey, like, what are the ideal criteria of trust assumptions? How paranoid do we need to be? What's most important is you understand where the points of failure are. What are the trust assumptions? And are you okay with those trust assumptions? You know, like maybe you're okay trusting Foundry, right? Because if you download Foundry, it's much harder for someone to, you know, break into your computer, adjust Foundry, whereas it's much easier for somebody to hack the safe website, right? It just is. Um, the trust assumption of your Foundry on your device versus the safe UI website is, you know, who are you going to trust, yourself or some random entity, right? It's much better to trust yourself and understand those trust parameters. So does that make sense? I know that's kind of like an abstract answer, but hopefully that makes sense. Reducing the single point of failure dependencies with redundancy is a great idea. Exactly. That new guy, spot on. Patrick, why is MetaMask a trusted wallet? So that's a great point. So I'm at this is where you might want to ask, like, hey, like, do I trust this wallet? Um, I think MetaMask is a great software wallet because it's open source. It's used by a lot of a lot of people. It has been through many rigorous security reviews. Um, but for like being a main signer, I would say no. You should use a hardware wallet instead. Um, But do I think MetaMask is a great tool? Yeah, I think MetaMask is absolutely a great tool. But you know, maybe you say, hey, like, how do I know the hardware wallet is a good tool? Like maybe that's busted. There have been examples of hardware wallets getting broken into and tampered with, right? These are just the things that, especially you all as technical folk, you want to understand. This set of signing exercises can be packed into a CTF security education game if you ever want to create a game. I think that's what I'm going to do. I think that's what this workshop showed me. That's definitely what we're going to do. If you have a hacked PC and you sign a transaction from your hardware wallet, can the hacker get your private key? Great question, Elamore. This is where your hardware wallet choice is important. So most hardware wallets will never have the private key leak. And this is actually why, again, we want to say, I only trust what's on my hardware wallet because they're even harder to hack, they're even harder to reach, especially if you never connect them to the internet, right? Most for most of them, the answer is no. Where they don't the private key is used in like a secure element different from like the rest of the computation on the device. So if your computer gets hacked, your private key on your hardware device usually is still safe depending on the hardware device. Most are still safe though, yeah. They cannot get your private key, but they could spoof the call data on your computer and send a malicious transaction to your hardware wallet. Yep. Great question. Unrelated question, but is there any competitor slash alternate of Chainlink? Let's keep this to wallet related questions. And I was supposed to create a type form. How does Phantom compare to MetaMask in terms of security? Um, Here's what I don't like about Phantom. Phantom is closed sourced. MetaMask is open sourced. I have no idea. Um, I can't. That by itself is usually enough for me to want to stay away from a tool. So, for like another example, so Ledger is closed source. I don't like that. Trezor is open source. I like that. Keystone is open source. I like that. Closed source. They could be, they could have a back door where someone of their team could, get the key. They could be doing some super secret way to transmit data out of the device. I don't like closed source, especially when it comes to security, is terrifying. There's a lot of people will say, oh, like, no, it's closed source as a security principle. If hackers don't know what the code is, then, that's safer. That's actually a fallacy known as security through obscurity. Hey, let's just make this really obscure and weird, and that's like secure. That's not how it works. Hackers have way more time than you think they have. And if they can, a lot of them will figure out how to debug your code, because it's going to be just compiled to assembly, and hackers who have enough time will decompile your assembly. Yeah, macOS is closed source. It's not great, which is why, like Cyfrin team, we do a lot of our work on Linux, which is open source. Do you consider anything 100% safe? Nothing is 100% safe. That's a great question. Nothing is 100% safe. There is no silver bullet to security. There's no silver bullet to security. What we can do is we can understand our security assumptions, we can understand our dependencies, and we can understand our weak links and fortify them. It's kind of like asking, is there a castle that is unbreachable? And the answer is no. There's no 100% secure. You can just make things sufficiently difficult for attackers, and you want to make them as difficult as possible. Even passwords are a good example, right? If you have a password that has like 8 alphabetic characters, a hacker can crack your hash in like a matter of seconds, right? But add a few more characters, and it takes them substantially longer to crack your password. So that's what we want to just keep doing. Just keep adding more and more layers of security. Can you download MetaMask from GitHub? You sure can. You can download MetaMask from GitHub. The whole thing. You cannot download Phantom. Hackers have no idea what my mother's maiden name is. I'm Gucci. That's funny. How can we use AI to improve wallet security and signing transactions? That's something I've actually thought about for a while. Like, it would be great if you had like an AI agent who like reviewed your transactions and like was like, hey, like this looks kind of spooky, and here's why it might be spooky. It might also be terrifying for like a privacy thing to like give an AI agent your access to all your transactions, obviously. Yeah, AIs can be tricked as well, so it would not be great if you relied on them. There's actually a team in Denver working on an AI agent power wallet. I think that's cool. However, I also know exactly how I would try to trick it, and that kind of terrifies me. So when you're downloading MetaMask as a Chrome extension, you're trusting Chrome with the download data, correct? A little bit. So your private key in your MetaMask is stored essentially in your Chrome or your Brave or whatever. So this is, again, where it would be better if you were using like an open source browser. Great question. All right, so we're 10 minutes over here. I was supposed to create a type form for you all to give us feedback on how this went. There are already a whole bunch of improvement points that I want to make the next time we do this. And yeah, like making a little multi-sig capture the flag sounds really exciting. Thank you all for coming. Hope you all learned something. I'll probably post a link to a type form or not a type form, some type of form to give us feedback on what you would like to see next or what you would like to improve on this. And thanks all, and have a great rest of your Saturday. All right, how do I end this event? Maybe I'll just sit here because I don't know how to end the event. End stage forever.